we should know the Gauss law equation. Rho v is equal to del dot d. Rho v is equal to del dot d, where d is electric flux density, and we know d is equal to epsilon E. Now rho v is equal to del dot epsilon E. Also E is equal to minus of gradient of V, means minus of del V. It is equal to minus of del V. Now this equation becomes del square V is equal to minus rho V upon epsilon. Okay, and this equation is known as Poisson's equation. If rho V is equal to 0, then del square V is equal to 0, and this equation is known as Laplace equation. Equation is known as Laplace equation. Now, sacred coordinate system is circular cylindrical. Circular cylindrical coordinate system. So del square V is equal to del dot del V. So what is del in circular cylindrical? In circular cylindrical, A rho del upon del rho plus 1 upon rho A phi del upon del phi plus Ez del upon del z. So what is del V? A rho cap del V upon del rho plus 1 by rho A phi cap del V upon del phi plus Az cap del V upon del z. Okay, so del dot del V, let this is vector B. If this is vector B, then divergence of B vector, formula of divergence in circular cylindrical, 1 by rho del upon del rho, rho B rho plus 1 by rho del upon del phi B phi plus del upon del z dz. This is the formula of divergence. So if this is B vector, then this is the value of B rho, and this is the value of B phi, and this is the value of Bz. So this is the Poisson equation in circular cylindrical. If rho v is equal to 0, then above equation will be known as Laplace equation. Third is for spherical coordinate system. For spherical coordinate system, what is del in spherical coordinate system? AR cap del upon del R plus one upon R a theta cap del upon del theta plus 1 upon R sin theta a phi cap del upon del phi. Now del v is equal to AR cap del v upon del R plus 1 upon R a theta cap del v upon del theta plus 1 upon R sin theta del v upon del phi, where v is equal to function of R theta phi. Now if this is vector C, then it is equal to divergence of C vector, and it is equal to 1 upon R square del upon del R R square C R plus 1 upon R sin theta del upon del theta sin theta C theta plus 1 upon R sin theta del upon del phi C phi. So if this is a C vector, then this is the value of CR, this is the value of C theta, and this is the value of C phi. So del square V is equal to 1 upon R square del upon del R, R square del V upon del R plus 1 upon R sin theta del upon del theta sin theta C theta plus 1 upon R sin theta del upon del phi C phi 1 upon R sin theta del V upon del phi. So del square V is equal to minus rho V upon epsilon is equal to 1 upon R square del upon del R R square del V upon del R plus 1 upon R square sin theta del upon del theta sin theta del V upon del theta plus 1 upon R square sin square theta del square V upon del phi square. So this is a Poisson equation. If rho v is equal to 0, then del square b is equal to 0 is equal to 1 upon r square del upon del r plus 1 upon r square sin theta del upon del theta sin theta del v upon del theta plus 1 upon r square sin square theta del phi square. And this is a Laplace equation. This is a Laplace equation.